Okay, guys, we're going to be moving on to Unit 6, Lesson 4, Determining the Scale. This is kind of a lesson that's kind of abstract. So when we look at this lesson, we're going to have to extrapolate a little bit and just talk it through just a little bit and make sure that we understand what we're looking for. But anyway, let's go ahead and get started here. Place the following numbers on both of the number lines, and you'll notice that this number line has an interval of 1, and this number line down here is an interval of a half. So, the bigger the interval, all right, the less descriptive it is. The smaller the interval, the more precise it will be. So let's go ahead and get started. Negative 1.5 would be about right there, okay? 3/4 would be about right there. 4/3, all right, well, 4/3 is an interesting one because that's equal to 1 1/3. So 1 1/3 would be about right there. And then negative 75 hundredths would be about right there. So right there would be negative 0.5. All right, so now let's go ahead and put these same numbers down here on a little bit more descriptive scale. Negative 1 5/10, negative 1 5/10. See, this and this is actually equal. 3/4, so here's half. 3/4 would be right there. 4/3, again, was 1 1/3, so I'm going to go to 1. And here's a half, so 1 1/3 is actually about right in here. And then finally, negative 75 hundredths. Well, here's negative 1, here's negative, about right in here, isn't it? Yeah. So you can see how the scale changed the location of our plots. Explain the similarities and differences between the two number lines. Well, one is like this one, all right, it's like zooming, right? It's like zooming in. The location, all right, is the same, right? It's the same, but it looks different. So it does. And why does it look different? Just because the scale is different. All right, so scale. The scale is the number by which the axis is marked. In situations with very large and small numbers, the scale, right, will need to count by something else. Okay, and you'll see how we go down through this. So, and really, if you understand it, it's hard to be wrong with this. Let me check my my camera there, make sure we're okay. All right, we are. All right, so let's go. So use the coordinate plane to determine the location of each point, then reflect each point across the x and the y-axis. And then we're going to lift those. So let's go down through and get our locations at first. Letter A is 1, and here's 1 1/2, 1 3/4. So letter A is 1 3/4, or 1.75 would be fine. Let's go to B. So it's going to be negative, right? We're going to go back, negative, right, 3/4, or 0.75, and then they go up to the first line, which is 0.5, or a half. Letter C is over 1 3/4. See how we come over? Here's 1, here's a half, here's 2, so it's in between those two. And it goes down to negative 1. Letter D is negative 2. That's easy. It's right on the line. And then down to negative 2. Okay? So instead of me counting and trying to move these things, what I'm going to do is just change the sign. And that's the most important thing. So when I reflect across the x-axis, and here's x, I'm going to change the sign, okay, of the second coordinate. Okay, and then I'm going to go ahead and make that plot. All right? So to reflect across the x, my new ordered pair is 1, negative 1 3/4. So let's talk about that. All right? Here's 1, all right, and negative 1 3/4 would put me down here. So that would be a reflection across that line. And I'm not going to plot all these since I have two coordinates, but we would call that A prime, right? Okay, so let's go to the next one. change the sign of that second number, right? First number stays the same. Second number is negative 1/2. Again, if I was to do that, all right, negative 3/4, negative 1/2, that would be B prime. Next one, 1 3/4. All right, I'm going to change the sign to a positive. Why? Because that was a negative 1. Now it's a positive 1. So 1 3/4, right? 1 3/4 and 1. And there's a reflection across it. And then the last one would be negative 2. That was a negative, so I'm going to change it to a positive. So negative 2 and 2. Okay. Now, let's go across the y-axis. The y-axis here. Okay. And to get across the y-axis, now I have to be careful with this. I have to go back to the original location and change the sign of the first number. Don't use the reflected act. Use the y, right? All right. So here we go. So instead of 1, it's going to be negative 1 and 1 3/4. I go back here. Instead of negative, it's a positive 3/4 and a half. And the next one is, since this is a positive, I'm going to make that a negative 1 3/4 and negative 1. I don't bother that second coordinate. I'm just changing the sign of the first. And then finally, this will be 2 and negative 2. Okay, so I've reflected across both the x and the y-axis. And how did I do that? I changed the sign. When reflecting across the x-axis, I changed the sign of the second number. When reflecting across the y-axis, I changed the sign of the first from the original location. All right, so let me pull that up a little bit. Which of the original points on the grid satisfy the condition where x is less than 2? X, left and right, is less than 2. All right, well, here's 2. X is less than 2. Well, right now I have D, B, and C. They're all less than 2. And Y is less than 1. Well, here's 1, right? Here's 1. So Y is less than 1. So letter D is 1. Absolutely, letter D is 1. Sure, it's less than 2. Letter B is 1. It's less than 2 and less than 1. What about C? Is it less than 2? Sure, it's less than 2. Is it less than 1? Absolutely, it's smaller than 1. So B, D, and C. Okay. All right, let's continue on here. Which of the original points, these are the originals, I didn't plot these ones, the reflections, which of the original points on the grid satisfy the condition where x is greater than negative 1? Well, here's negative 1, right? And I'm going to square this one. X is greater than negative 1, and y is less than 1. So it has to kind of fit in between those two, right? So let's take a look at B, right? So B is greater than negative 1, and I made a mistake. We're not using that one. We're going to use this one. But B is greater than negative 1 because it's above it, and it's less than 1. So B works. It's great. It's right there. How about letter C? I think we have one more. Letter C, right? Okay. So letter C, is that greater than negative 1? Yep, right there. And is it less than 1? Yeah, it's down below, right? It's below the x-axis, so it is. So it meets both of those requirements, and those are the only two that fit this rule. Okay. Getting a little bit more into algebra as we get more abstract. Okay, let me check my mirror here, make sure we're in good shape, and pull this back down for you. Okay, and let's continue on. Okay, so an appropriate scale, PR, I don't want to misspell that. An appropriate scale can be determined by reviewing the set of data. Now, this is kind of where you can't be wrong, okay? And if you just take your time. All right, so use the coordinates below to determine what the scale should be on a grid, on a plane that's 20 by 20. So what I kind of like to do is kind of look at my ordered pairs, and I see the biggest number is 9, and the smallest number is negative 6, right? And I like to go 1 or 2 above it and 1 or 2 below it, okay? So, all right, I'm thinking I need to get from -10, which is a little bit smaller than this, to about 10, which is a little bit bigger than that. And this is pretty easy. All of these intervals are really just integers. There's no decimals there. So I'm just going to count by ones. Now, let's take a look at this one. My biggest number looks to be 18, and my smallest number is -16. So my spread is pretty big. So we're going to go from -20 to 20. Now, remember, I have a grid of 20 by 20, so I can't go any bit bigger than that. So I'm going to make my interval just a little bit bigger, and I'm going to count by twos. There, count by twos. Okay? All right. But again, these are still all integers. There's no decimals. Now we're going to get into some rational numbers, right, that have that. So we're going to be a little bit more descriptive because we have more precise, right? So that means my intervals or my count's going to be a little bit smaller. My smallest number here is -2 5/10. So I'm going to go down to -5 to about 5. So that's really a spread of 10. And since I have decimals, I'm going to make it a little bit small. I'm going to count by halves or 0.5s or 5/10, right? Okay, this last one. Let's look at our data spread. Now, I notice that I have a lot of fractions here. A third, a half, 2/3. I also notice that my smallest number here is -1.5, and my greatest number is 2. So when I look at this, I see that I don't have a big spread of data, so I need to make my count even smaller. So I'm going to start at -3 and go to 3. And I'm going to go a little bit smaller than a half, and I'm going to count by a thirds. Okay, I'm going to count by a thirds. And when I count by a thirds, I'm really going to be descriptive on where I put my plots, all right, on the grid and on the coordinate plane. And you'll see how all this fits down the line. Okay? All right. So take notice of the scale below, then match each point in its ordered pair using the graphs. Okay. So a scale here is 1. So I just have to be very careful. So I'm -2, -3.5. Remember, first number left and right, that's letter N. Let's go to this one. 3 seconds. Well, I know 3 seconds is 1.5. So 1.5. And 2 3/4. And look, it's not on the line, so it's right there. So we'll call that letter L. All right. Now, you can use your calculator if you need to. -5/2 is -2.5, right? So that's really -2.5. And that takes me back between these two and 2. So that's going to be the letter K. And then finally, 3, just by process of elimination, we could figure out that it's M, but 3, all right, and then -3 seconds. Well, that's -1.5, which is letter M. And again, your calculator will do that, but you should be able to do a lot of that mentally. Okay, so the last part is writing the ordered pairs of these. All right, and we kind of have to figure out our own interval here, right? All right, so let's see here. W. Well, W is on the line, so really I'm just going to go ahead and make my intervals. Oh, I'm sorry, it's -2.5. I made a mistake there. Let me erase that. I didn't see that. Okay, so we need to decide what our interval is here, right? This is 2.5. So what is this going to be? 0.51, all right, 1.52. So our interval is a half. So this is 0.5, 1.5. This is, all right, 2, all right, 2.5. That's not going to work either, is it? So what can we do there? 0.51, 1.52. No, I made a mistake there. That was right. 0.51, 1.52. -0.5, -1. Right? negative 1.5, negative 2. Okay. 0.5, 1, 1.5, 2, negative, right? And again, I could go with, I could change it to fractions if I wanted to, right? Negative 1.5, negative 2. Sorry about that, but hey, that's all learning, right? Okay, so let's look for W. W is here. So I go over to the line, and that's 1.5, right? Or 1.5. And then I go up. So I go up, I'm between 0.5 and 1, which is 0.75 or 3/4. So I'm just, going back and forth between decimals and fractions. All right, so let's go to letter X is right here. It's not on the line. It's between 0.5 and negative 1. So it's going to be negative, right? Negative 3/4 or 0.75. And down, right? And down. Well, here's negative 1 and negative 1.5. In between, exactly halfway is 1 1/4 or 1 25/100. But I'll write it as a fraction. I got to make sure I put my negative there. Letter Y. Y is 0.5. No, it isn't. It's in between 0.5 and 1. So it's going to be, 3/4. You see? And then we're going to go up to 1 5/10 or 1.5. And then finally, letter Z is back here. So here's the origin. I go back to negative 1 1/4, right? And you have to know your fractions, right? Negative 1 1/4 and down to negative 3/4. It's between 1/2 and negative 1, negative 3/4. So this was pretty tough here. We had to figure out the interval, which I made a mistake on it, but I corrected it. And then I switch back and forth. Sometimes I use a fraction, sometimes I use a decimal. And you should be able to do that mentally, especially when we're talking about halves and fourths and 3/4. Okay? All right, guys, go ahead and start on your homework. Thanks.